All right, so here we go on notes 3-2, and I want you to pay careful attention because now we're talking about you're proving the lines are parallel. So we're going to say this over and over again, but this whole lesson is going to be the converse of lesson 3-1. So in 3-1, Euclid gave us the rules of if the lines are parallel, then all these cool relationships are true. And for every single one of these, then the lines are parallel, then the lines are parallel, then the lines are parallel is going to be our key component of conversation. So now it's backwards. So if the two lines and the transversal form a pair of congruent corresponding angles. So this is saying if we have congruent corresponding angles, if I have this angle is congruent to this angle, then the lines are parallel. And notice it's now the converse of that postulate. Okay? So now we have our second postulate, but our fourth and fifth and sixth theorem. Okay? So the postulate's what he gave us. The theorems are what we can end up proving, and we will. Okay, so the converse of the alternate interior angles theorem is going to say if you have alternating interior angles that are congruent, then the lines are parallel. So we get our parallel lines after we know this is true. We get our parallel lines after we know that this is true. So we're going to have to really keep straight whether we're talking about the converse or whether we're talking about the original theorem. In the original theorem, we're given the lines are parallel. In the converse, we're questioning, are the lines parallel? Well, guess what? I've got consecutive interior angles that are supplementary. So if they are supplementary, then guess what? They add up to 180 degrees. If that's true, then I've got me some parallel lines. So now I'm proving that the lines are parallel. If two lines in a transversal form congruent, alternate exterior angles. So we have these angles that are outside and opposite, and they are congruent. If we have this story, congruent, alternating exterior angles, then guess what? We can say with confidence that the lines are parallel. So it's going to be real important that you just keep straight what you're given and what you're proving. You're going to have to really focus on what question is being asked of you. All right, so let's take a look. Which lines are parallel if angles 1 and angle 2 are congruent? All right, so if I have angles 1 and angle 2 are congruent, we have to talk about where's our transversal. Is this our transversal? I don't think so. Is this our transversal? No. This line includes angle 1, or at least part of it. This line includes angle 2. Is this our transversal? No. No. So here we have the transversal that defines and relates these two angle families. So now I have to figure out, okay, well, which lines am I talking about then? If those are our two angle families, which lines am I talking about? Did you get it? That transversal is going to relate C and D, and you might have to sometimes turn your paper to have it make sense to you, because now you can see that line angles 2 and angle 1 are alternate interior angles, and they are created by this transversal, and they are alternate interior angles are congruent, so therefore we can say that lines C and D are in parallel. And when we do our symbol for a parallel, it's just going to be two of those longer lines. If you're looking at your keyboard, it's going to be the line, the little symbol underneath the backspace or the delete, depending on what computer you're on, but just your straight up and down signs. All right, let's flip the page, see what's over there. Awesome. We have a proof. Yay. Okay. They want us to prove the alternate exterior angles converse. Okay. So, wait a minute. What? Let's go back and look at what that is. The alternate exterior angles converse. It says if two lines of transversal form, if these are congruent, then the lines are parallel. So I'm proving that the lines are parallel. So I'm going to be given that two alternating exterior angles are going to be congruent. So you're given angle 1 and angle 2 are congruent. So that is always our fastest and first answer that we like to give. I'm proving that M and N are parallel, so let's go ahead and write that in because I'm hoping to get that done. All right. Angle 1 is congruent to angle 2. That's given. Angle 2 is congruent to angle 3. Oh, you don't say, huh? Those look like what? Vertical angles to me. So our vertical angles theorem is going to go ahead and justify how I know that's true. All right, well, guess what? Now I have corresponding angles are congruent. Angle 1 is congruent to angle 3. How do I know that that's true? Now, angle 1 is congruent to angle 2. Angle 2 is congruent to angle 3. Do you see this link? Do you see? So my transitive property of congruence is going to make that a true conversation. Awesome. Congruence, because we're talking about angles, not measures. All right, so now, and this is where we get to use the postulate that he gave us. If you have corresponding angles congruent, then my lines are parallel. We'll rock on. He said it. I've got corresponding angles congruent, so therefore I know that they're parallel because of the converse of the corresponding angles postulates. All right. Proof number 1 in the bag. You're amazing. All right, now I got to apply the alternate interior angles converse. Okay, so we're going to solve for x. So we have these two things here. So I know that the alternate interior angles are going to tell us when I solve for x, I need them to be the same measure. So we'll go ahead and say 6x plus 34 has to be equal to 9x minus 2. So we'll go ahead and add 2 to each side, and we'll subtract 6 from each side. So we'll get an x value of 12. So if I want these two angles to be the same measure, x has to be equal to 12. And if x is equal to 12, it looks like, let's see, how big are they going to be? 6 times 12 is going to be 72. So 72 plus 34 looks like I'm looking at 106 degree angle. Does that sound right? 108 minus 2, yeah. 106 degree angle. So let's see what this says. Lines P and Q will be parallel. Okay, they will be parallel only if the marked angles are 106 degrees, and we can say that's because of our alternating interior angles converse. I know if I can get these two angles equal, the lines will be parallel. If x is equal to 12, that's a true story. So then I can go ahead and say that those lines are parallel. All right. So this is a really funky diagram that I want you to take a peek at, but it might help you to separate it. So if you can think about this, I went ahead and pulled out certain colors. So here's AG, here's AG, here's CE, here's CE. I should have gotten my straight edge. So if I look here, and again, don't be afraid to spin your paper. If I look here, I have alternate interior angles, and are they the same measure? No, they're not. So guess what? These ones are not parallel. Let's take a look at these ones. Here I have BH, and here I have DF. And there's my 67 degrees. Are those alternating interior angles congruent? Yes. So yes, these ones are parallel. And this 113 degrees was the result of this angle addition, and this 117 was the result of this angle addition. So that problem is pretty tricky without my hint. Not so tricky with the hint. All right. Suppose the measures of angle 1 and 2 are in a 4:11 ratio. Find the measures. Diagram is not to scale, so we can't always trust. Okay, so angles 1 and 2 are in a 4:11 ratio. Let's talk about what that means. That means that I had a simplified fraction that I simplified by 4/11ths. All right, so let's take a look at this diagram and figure out what we know. First of all, do you see these triangles down here? Because I know that the lines are parallel, I know I can say relationships are true about, and we'll start with 1 and 2. They're consecutive interior angles, so I know that the measure of angle 1 plus the measure of angle 2 has to equal 180 degrees. And you know what I'm going to do? I'm going to say the measure of angle 1 is going to be my x value, and the measure of angle 2 is going to be my y value. So this whole thing about this 4:11 ratio, let's talk about what that means. That means that this 4:11 ratio is what I have between my x and my y, my measure of angle 1 and my measure of angle 2. So I can go ahead and write a couple equations about that by doing cross products. 11x is going to be the same as 4y. And I can say that x is equal to 4/11ths of y. So then I can put that back into, and remember, if I have x and y, 1 is x, 2 is y. So then I can go ahead and say, all right, if x plus y is equal to 180, and x is equal to 4/11ths of y, then I have an equation I can solve because I have matching variables. So this y is 11/11ths, so that's 15/11ths y is equal to 180. If I multiply each side, let's get a pen. This is getting a little messy with my markers. Multiply each side by maybe a pen that works, 11/15ths. Then I can have my value for y, which is going to be my measure of angle 2. So then y is equal to, let's grab our calculator, and we'll go ahead and clear, and we'll say that 180 times 11 divided by 15 is going to be 132. So y is 132. That's my measure of angle 2, 132 degrees. And because these are supplementary, that means that 180 minus 132 is 48. So we have 48 degrees. So if, remember, my lines are going to be parallel. If this one's 132, so is this one. And if this one is 48 degrees, so is this one's 132. So we can go ahead and have that conversation, But what was confusing to me was I originally started off saying, okay, 60 minus 2x has to be equal to 2x minus 60. Anybody do that? Now, I know these angles are congruent because they're corresponding, but do you see what ends up happening here? I get 4x is equal to 120. I got x is equal to 30. And when I put this into that, I ended up with some pretty ridiculous things because I ended up getting zeros. So I can use that relationship to solve for what those angle measures are, but it's a crazy problem because we have that contradictory information. So how about that for a challenge?